Hi, welcome to RVSP series lectures. So now I am going to discuss about moments as part of operations on random variables. So what is a moment? So generally this moment in the probability moment of a random variable will gives the distribution of the density function. So there are two types of moments. The first one is moment about the origin and second one is moment about the mean. So we need to discuss one by one separately in detail. So let us take the first one is moment about the origin. So here the moment about the origin is going to be taken with respect to 0 point of the graph. So for this I am taking one function simply g of x, which is given by x to the power of n for n, so for different values of n. Okay, so here the moment about the origin is simply expected value of the g of x, which is expected value of x to the power of n. So this is called moment about the origin, and this is given by simply integral minus infinity to plus infinity x to the power of n fx of x dx. And this moment about the origin is simply represented by m suffix n. Moment about the origin is indicated by m suffix n. Here, this n represents the order of the moment. Order of the moment. And this is the equation for continuous random variable. For suppose if we have discrete random variable, then the function is given by mn is equal to expected value of x to the power of, so sigma I is equal to 1 to n xi to the power of n probability of xi. So this is the value of moment about the origin for discrete random variable. So now I am taking two examples. If n is equal to 0, what happens? So let us take with this continuous random variable case. So if n is equal to 0, this is represented by m naught. So expected value of x to the power of n. What is that meaning? X to the power of n means it is 0. So you can take this as 1. So the value is 1. Okay. So now if n is equal to 1, so m1 is equal to expected value of x. So this is integral minus infinity to plus infinity x fx of x dx, which is represented by simply x bar, the expected value of x bar. Therefore, m1 is equal to x bar, m0 is equal to 1. This is a predefined values. You can remember these values for problem solving. Okay, and next take the moment about the origin. Take moment about the mean. So an average value is going to be taken, and what is the distribution of the function about that mean is going to be calculated here. And for this function is taken, you have x is equal to x minus x bar whole to the power of n for n different values, and mu n is equal to expected value of, so the moment about the mean is always represented by mu n. Moment about the mean is also called as central moment. Central moment, and it is represented by nu n. Mathematically, it is expressed as expected value of x minus x bar whole to the power of n, and that is given by integral minus infinity to plus infinity x minus x bar whole to the power of n fx of x dx. Okay, again we will try to take different values of n. So if n is equal to 0, what happens? So nu naught expected value of x minus x bar whole to the power of 0, and directly I can take this as 1, and expected value of any constant as per the property of the expectation, we can take this as 1. And if n is equal to 1, nu 1 is equal to expected value of x minus x bar. So I can take this simply. So that is e of x minus e of x bar. But expected value is always a constant. So e of x bar is nothing but x bar. But e of x means x bar only. So x bar value is 0. So the first order central moment. This is 0 order central moment. The 0th order central moment value is 1. And the first order central moment value is always 0. Try to remember this value. And the very important parameter we are going to discuss, that is variance. So when you have the density function f(x) of x, then this variance is going to give the measure of spread in the function about the mean. So if suppose I'm going to have the density function, Gaussian density function is like this. So this is the mean value x bar. Okay, and how much it is deviated toward this one and toward this one with respect to standard deviation sigma or sigma x. So like this, if I'm taking the density function of this, and when you go for the definition of the variance, the second order central moment, that is nu2, the second order central moment nu2 expected value of x minus x bar whole square is taken as variance, and you can give the formula integral minus infinity to plus infinity x minus x bar whole square fx of x dx, and this is also represented as sigma x square. This is the variance value. Sigma x is called standard deviation. Standard deviation of random variable x. Okay, so how much it is deviated toward this direction, toward this direction. So if I am taking like this here, then x bar plus sigma minus sigma and x bar plus sigma, like this. Sigma is the deviation, how much amount it is deviated from x bar and before the x bar value. Okay, I can express this standard deviation as square root of nu2 simply, or square root of expected value of x minus x bar whole square. Okay, and now I'm going to take one simple derivation which is going to give the relation between the variance and moment about the origins, the first order moment and second order moment about the origins. Okay, so how to get? So for this I'm taking the second order central moment nu2, that is equal to sigma x square, which is expected value of x minus x bar whole square. Now I'm going to use a minus b whole square formula, then x square minus 2x x bar plus x bar square. So you can apply properties of expectation, then e of x square minus 2 e of x, and there is no need to apply for this x bar, and here also no need to apply because expected value itself is a constant value and no need to apply again expectation for that constant term. So the e of x square minus 2 e of x is x bar only, so already x bar is there, plus x bar square, and e of x square 2 x bar square plus x square. So expected value of x square minus x bar square. So what is E of x square? It is the second order moment about the origin, that is nothing but m2, minus this is x bar is the moment about the origin, the first order moment, that is m1. So already square is there, so square. So then the second order central moment or the variance is equal to m2 minus m1 square. This is very important equation. You can remember this to solve different problems, and you may get this simple derivation for 2 marks question in the examination also. And based on this, we are going to define a new term which is called as skew, a skew. The third central moment, which is represented by nu3, is called skew of the density function. Nu3 is called skew of the density function, and it gives the symmetry of the function f(x) of x around or about the mean value, that is x bar, the mean value of the random variable. If any function f(x) of x is symmetrical about the mean, then the skew value is 0. That is, if I am taking this one function about the origin means, so this is and this is. So if the function is symmetrically distributed, how much on left side and how much on right side? If it is symmetrically distributed on the two sides about the mean, okay, about the mean, so then, so just I'm taking reference as x bar here, about the mean, then that is called then the skew value is 0. That is nu3 is equal to 0. Okay, and this is valid only for when n is equal to odd number. Maximum n is equal to odd number is taken for getting skew value is equal to 0. And there is one more term which is called as skewness or coefficient of skewness, which is given by nu3 divided by sigma x cube. This term is called as skewness or coefficient of skewness. So this is about the basic definitions and equations of moment, variance, skew, and skewness. The topics are very important to understand different concepts in the communication and even in the probability. Thank you. Thank you for watching.